to have Eric with us. Eric, we are going to bring you on camera as we don't see you yet. And good morning, Eric. Jeff,
morning.
on.
Hey, good morning, Eric. This is Jeff Hammond. How you doing?
I'm doing great. How about yourself?
I'm doing quite well. We've had a pretty busy week, and it's going really well. And just really excited about bringing your organization in here and getting educated about what's going on with MAHLE Motorsports and what's good for 2021. But can we back it up a little bit? Tell me a little bit about your personal background and how long you've been working in the business.
Well, I started with MAHLE actually almost 18 years ago, and unfortunately, or fortunately, depending on how you want to look at it, I've been a piston engineer my entire career, so that's all I know, good, bad, or indifferent. And of those 18 years, the last 15 have been in motorsports exclusively, transferred over to the division, and have been working with them in a variety of different facets. Actually started as an application engineer, where I was doing project work for customers and teams directly, failure analysis, performance analysis, looking at parts, reviewing, et cetera, and transitioned from there into doing actual design work. Got involved in some of the CAD work and putting parts and ideas to paper. Eventually became engineering manager. Did that for a few years, and then look at my current title. It says product manager, but really that just entails kind of responsibility for engineering, sales, marketing, and all the facets under that. But it's, I think, kind of interesting that it's one of those positions where you never really lose any responsibility. You just keep adding. So everything from still answering tech calls and stock checks as guys come in to kind of keep a pulse on what's happening in the market and with our customers. That part's never been too far from where I'm at.
Well, with that being said, also read somewhere that MAHLE is originally a company based out of Germany. Is that right? And it's like 100 years old this year.
Yeah, actually 100 years in one day. December 1st, 1920, they started their first series production of aluminum pistons, two brothers in a very small workshop over in Germany. And from that very small start, they've grown into this global entity that they are today, obviously diversifying in both size and scope. Now it's 160 some production locations in 30 countries and 70,000 some plus employees. And they've diversified from that start in pistons to almost every component in the engine, in addition to getting into thermal management and filtration and all the systems that support those as well.
Okay, with that being said, I guess you threw a bunch of things that may have come to my mind. So where in the United States, where are you located at, and just how many production companies do y'all have within the United States?
I lose track as well. There's probably a half dozen to a dozen companies that MAHLE encompasses. But even for everything that MAHLE does, we're a very specialized portion of that company, us Motorsports per se. We make, even though MAHLE may make all these components in different parts, we make forged pistons and rings for the performance and racing industry. Yeah. I'm sitting right now in Fletcher, North Carolina, which is where our small satellite sales and engineering office is. But production of every part that we produce for Motorsports happens just about an hour north of us in East Tennessee, Morristown, Tennessee, actually. And so we've got production facilities there that we make the parts, and any of our WDs that happen to be listening, that's our central hub for distribution, and everything is packed and shipped out of that location as well.
Okay. So let's talk a little bit about, the process. You've been in the business for 18 years. I'm pretty sure you've seen a lot of things. I mean, first thing you got to do, you got to identify what are you making it for? What does it expect to do? And it's got to go through a process of design and I guess you might say you got to fail this part before you can put it into production. So give us some overview of what it's like, going from like I say, I walk in here and I say, hey, I got a 6-cylinder engine here that I'm running. I'm trying to make a special design deal for a straight line 6 that I want to run at the Bonneville Salt Flats, and I want to do this, 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 and this, and I need your company to help me come up with something that I can make a ton of horsepower with. You know, what would, if I come with you something like that, or I want to build a special drag racing engine that I want to, you know, go run in the NHRA. You know, what is the process and how does it work?
Jeff, you were close. You touched on probably three of the most important things that come there. And one is I want to make a ton of horsepower, but you left out I want it as cheap as possible and I want it to last forever. You know, not specific to pistons, of course. That's any component that we deal with. But no, what I kind of wanted to talk about today is sort of why we ask the questions we ask, because there's almost well, it starts with when a guy comes to us with an application, you're looking at what you've got off the shelf. Is there a catalog part that fits that application? Because that's always the quickest and cheapest way to put them into a good quality part if it matches their application. And right there, we're probably touching on a word that I will use frequently today, and that's application, because matching the parts to the application, there's very seldomly a right or wrong part. It's what's right for the application, and understanding what that part needs to do, what the requirements are. That's the bulk of the work. How to get from there, once we understand, and putting it in onto paper and in the computer and actually cutting chips, that's kind of the easy part. But making sure that we know exactly what that application is and what it is expected to do, that's the real bulk of the work. But there's also, I don't want to call it hesitancy, maybe even stopping just short of calling it annoyance at times, when it almost seems that, you know, if you're trying to order a piston and you've got something in mind, the questions that get asked, in the back of the mind, in my mind, I think there's this question of why are we asking those questions, and not seeing the full relevance of how everything starts to interact. And it's an issue that crops up occasionally. It's, you know, I'm not trying to lay a blanket on everybody, but you'll see it from the novice garage builder all the way up to professional engine builders. Sometimes the professional engine builders that should know better are almost the worst culprits. Because if you ask me for a piston that, you know, has X compression height, this pin, I'm going to run this rod, and I want it to be this compression, in your mind, and in most cases, you've probably outlined every specification that's needed to make that part. But sometimes there's subtle differences. When you start stacking things together, the rings are running into the pin, or there's not room from the pocket to the groove. So that leads to more questions, information that wasn't provided up front, that we then have to glean to understand, okay, what can we change or what can we compromise and still meet ultimately the end goal of what you're looking for. With the novice, it's the opposite of that. It's, I need a piston to fit this application. Tell me what I need. Help steer me in a direction that guides me, you know, using the expertise and knowledge that you have to be able to get a part that's going to meet what they're expecting it to do and fit where it needs to fit.
It's almost like some people are too smart for their own good, and they're trying to do your job to a certain degree rather than coming to you and saying, here's what I got going on, and work it from that point. And I'm not like putting anybody down. I'm just, because again, you know, you hear people, and we always want to make sure there's a lot of us out there who want people to be impressed with what my knowledge is what I'm trying to say.
Well,
your specialty is building that application. And again, you know, it seemed like you break it down to a simpler level with your last response, which was just give me what you need, because this is what I want. You know, just I need this for this application, and get out of the way of it.
I'll be the first to admit there are many people way smarter than myself. But what the big difference is visibility. Is you as the engine builder or the customer have all the components in front of you. You can see everything that's coming together or know what you intend to do. That visibility doesn't exist on this end of the phone. So in some ways, we've got this very small piece of information, and we're trying to build a part with, you know, not our hands tied behind our back, but, you know, we don't have access to what's on the other end. And sometimes we have to pull that information out to be able to understand what we need to be able to give you the part that's going to fit the application.
Well, I tell you what, let's go through one of those processes right there. Give us an example of something that maybe we would find, educational and informative at the same time of what even those steps are. I mean, you give us, can you be more specific?
Let me bring up the screen. I've brought up some data here that we can share because if you noticed in the background, there's way more emphasis on the engineering side than the sales or marketing. So this is not a sales pitch, and I'm a big fan of data.
Right.
So we'll share some of this here if we can. Let's make sure. And just to guide, I pulled up kind of information, graphics, visuals of different things that I could think of. So, we'll certainly open this up to questions, and we'll jump around if we need to and touch different topics. More than happy to do that on basically open to any question on pistons, and hopefully there's some insight that we can provide there. But just taking something as simple as a connecting rod. There's basic rod length, there's small end width, and those are some of the starting points for every piston. But when you sit down and kind of think about all the things that can be affected, and I made just a quick list of pin boss spacing, which is critical, clearance from the rod to the undercrown, the shape of the radius where the pin boss meets the crown, which is important for strength. And when you start getting into some of the specialized applications where you have boxed pistons and struts, making sure that rod angle will clear the strut, then the bottom of the piston becomes important. There's factors with these long stroke engines where they start pulling pistons out of the bottom of the block. And it's important for us to know where that is or how much that piston sticks out, and in some cases being able to calculate what that is. Likewise, the clearance to the counterweight of the crank, which is going to be affected by what rod length you put on that crank, which in turn helps us check and calculate inertia for that part. And deck clearance, if we have to go back and check compression, some of those things are relatively easy to do. And that's a case where, using the engine builder example, he or she, may tell us that I want a 11-to-1 piston with a 8cc dish and everything else is well defined. We're going to do our due diligence and kind of double check those compression numbers just as a sanity check, because the last thing we want to do is perpetuate a mistake or send something, by the time you've made and produced a part and shipped it and then find out that there was an addition error, that's a long way to backtrack and start over. So if we do the math, something doesn't quite add up, that's where it gets back into, okay, you told me exactly what you want, but now the pieces aren't connecting. What's the data that we need to be able to go back and calculate where we bring that back together? So, just looking at something like that's as simple as a connecting rod, other than having to fit in the piston, sometimes you don't think about the impact that it can have, but there's intricacies in how the small end is shaped, not just the width. And when you start looking at, again, long stroke motors that require very short pistons, and your rod is running into the underside of the piston, just the shape of that rod can make or break sometimes what you need for clearance, and not having to make compromises or determining what compromise is the best to work with the components that are available.
Well, again, when you were showing all that right there, a lot of things were coming to mind, but it makes itself so much more clear when you understand how the package has to start to go together, on all of that.
As I was putting information together and you start clicking through, and it almost became, I don't know what order to put this in, because what I had listed up here then becomes tied into a variable that's down here. And then once you figure out this variable and you're calculating it, it's also used 3 steps down the road, because there's, there is no disconnect from one singular feature. And that's the job of the piston manufacturer, is to tie all those variables together to be able to know that again, it physically fits the package that you need, but also is going to perform in the manner that it needs to, whether that's power, durability, longevity, any, sometimes just survive. But there's a host of factors that come into that, and tying all those variables together is what we like to do daily.
Well, what I was going to maybe say is that, continue what you started here, and let's look a little bit deeper in that, because as you go through the rest of this thing, I've got a couple of questions that may be better asked after I've seen the whole or better, more of the presentation, because I think it brings questions back for me, working through the series that I'm working in currently, as far as the outdoor, truck series there, NASCAR truck series. And, since we are running, the Ilmore engines, which, are pretty much, all one and the same, but some of the problems you come up with trying to deal with other series, how you approach that in your realm to make sure that the durability is there, and we don't have, we're actually putting a lot of miles on these engines before they ever get a chance to come back out, and how you address that. So carry on.
Yep, certainly. So just one of the variables we talked on, looking at counterweight clearance, just a visual to tie that in together, and don't put too much emphasis in some of the sheets we've got hidden in the background. Really, the point that we're trying to drive home with that is that for all these questions and variables that we're asking for, there's some calculation that's going on behind the scenes to determine something about the design of that piston. And that's just kind of the reminder that we put there of what we're looking at. But, and where it starts to tie together, if we're looking at counterweight clearance and how the rod length affects it, all that's going to be factored into inertia calculations, and leads into the question of really what RPM range are you expecting that engine to run into. And inertia failures are typically pretty spectacular, unfortunately.
I've seen a few of them along my history.
Yes, I did not have to search long for a picture, and that's I'm not criticizing any parts, engines, etc. But a lot of what happens is there's variables that are outside the control where you can't unexpected RPMs, other breakages, etc. And there's all kinds of reasons. So I guess in short, I'm saying I'm not afraid to show some broken pistons, because we certainly won't hide from the fact that we've seen a few. But you make compromises in terms of always wanting to protect against the variables, but you can't overprotect, because then you have pistons that are hitting counterweights on cranks, or you run into other interferences, or the parts get heavy. So everything is a balance, and it's about, again, the compromises that you make to balance out all of the factors that you're looking at. Sort of an interesting one that also stems from RPM. We talk about inertia on the piston. There's things as simple as the circlet that's affected by inertia. Our preference is to use a round wire lock. I think those that aren't familiar, just instead of a traditional square cut groove, uses a round wire lock. We like them for ease of installation, but it's also a very secure way to fix the pin. In terms of, there will always be some side-to-side movement of the pin, and when that occurs, the chamfer, in addition to that round lock, is actually pushing the lock, not just trying to push it out against the material that's supporting it, but you're pushing it into the piston. There's two vectors here in terms of that direction. So in some ways, the more force you put on it, the harder it's trying to push that clip into the groove. But there also have issues where the mass of the lock itself can be affected by inertia and RPM. Now, to put that into perspective, is it something that the average guy needs to worry about? If you look at a 927 pin, a typical small block Chevy with a 4-inch stroke, long stroke, meaning high piston speed, that inertia starts occurring 9,000 RPM. Not undoable, but not probably your average builder and a few exceptional applications. It changes when you look at a big block application. You've got a different clip geometry, but some of these big blocks that have 4 3/4 inch strokes, that's a lot more piston speed. And you can see where that drops down to, you might see some issues when you start touching close to 8,000 RPM. But does that mean that, the engine hits 8,000 RPM and snap, the clip springs out? No, there's other factors that come into that. And one of those is very simply the location of the clip. If you've got a gap where the mass of the clip can compress and act upon that gap, that's where you can have a tendency to see some clip ejections, or a possibility of it, where if that clip is rotated 90 degrees, now that mass that inertia is working on can't close the gap. So simple changes like that will have an effect, and it's not by any means an instantaneous number, and it takes some duration and time spent at RPM to be able to actually realize that. But again, it's those aren't numbers that are outside the realm of where engines can run. So it's considerations that again takes information and data from the customer to know how the engine is going to be built and how it's going to be used to start to calculate some of those things.
We're starting to get a few questions here, and I'll make sure I don't go too much longer without addressing those. Tom Noack wants to know, are you using anything as far as different type of alloys other than 2618 or 4032 in your product?
No, we actually have an internal alloy that's a variation of 4032 that we use. So technically the answer is yes, but for intensive purposes in this discussion, let's say 2618 and 4032 are certainly the most prevalent. And it's pretty, I don't know whether it was coincidental or they were just, smarter than we are today, but 2618 has been around since the 30s or 40s when Rolls-Royce developed it. And that alloy has stood over the test of time for the last, I guess that's 70, 80, 90 years at this point, which is fairly amazing if you consider the advancements that have happened in material science over the last 5, 10, 15 years.
Right.
That doesn't mean that we're not looking, and every other company out there is doing the same, and we're continuously evaluating materials and looking for new options. I can tell you to date, you're not going to see a lot others in any type of high volume production. There's some very specialized, very expensive materials that are doing good things, but able to have them to where they're ready to bring to market. I can say personally, we're still a ways off from that, but we never stop looking. But certainly the predominant materials are the 2618 and 4032.
And this again, while we're in the very early part of this discussion of the piston and developing the piston, is anybody, and this is Robert Samuelson who asked the question, is anyone using 2-piece pistons or piston cooling jets? And as what is the typical max piston velocity?
I don't know that I can put a quick number to max piston velocity, because
Right.
it's very, very seldom do we have the opportunity to dictate that. It's the other way around, where here's how fast it needs to go, protect against this, and make the part live at the piston speeds that are going to be dictated by the RPM and stroke of the engine. Cooling jets are very prevalent in upper race series. We're seeing that trickle down more and more. There are, at this point, tons of automotive OEM production engines that are cooled from the factory. So as it's become more prevalent there, I think we're seeing more of that trickle down to some of the lower series. But again, it all depends on that application. There's a lot of engines that you can create and build the durability that you need without it, but there's others that there's no way that they would survive without cooling the piston. Mm-hmm. So yes, they're out there. They can be used. It's a great tool when heat is a factor, and tying that back into alloys, as great of an alloy as aluminum is, 2618, 4032, it's also a terrible alloy for pistons, because as soon as you put heat to it, it starts to lose strength. and over time. And that's, maybe not measurable on a small scale, but in the theoretical level, and certainly in terms of, engines that are run at full power for long durations, and where that part has been optimized specifically to that engine. Let's take the Cup Series as an example. Back when those engines were one race, 500 miles, at the end of 500 miles, those pistons were done. They may come out of the engine looking perfect and brand new, but the integrity of the aluminum was such that the strength had degraded. You start to lose hardness of the parts, and they weren't going to go 600 miles. They would go 500 miles because they were optimized for that, plus qualifying whatever else you needed. And that was the big challenge when, a few years ago, when they went to the 2-race engines. How do you take a part that's optimized for 500 and now we have to double it? And again, it becomes, what compromise do we make? Cooling's a big factor of that, tune-up's a big factor of that, and some changes in the parts themselves. But it's about managing, again, all the variables that are building towards what that application needs to do.
Okay. All of this questions and answer you've given, you've already stirred up a lot of people asking questions, the difference about forged pistons instead of cast pistons, and folks saying, is there a high boost gasoline engine that would benefit more from a steel piston versus what's going on here? I mean, so this is the kind of, you got people out there got the wheels turning.
Yeah, touching briefly on the steel pistons, I still think that's the future. It's old technology in diesels. Diesel engines, your over-the-road trucks have been running steel pistons for 20, 30 years in some aspect, whether it was a hybrid of steel and aluminum or all steel pistons, which is most prevalent now. There's lots of work being done developing them for OEM engines. There's work being done on the performance side. They're being raced in certain series. It hasn't quite caught up to where I would call it mainstream yet. But there's also, it's not as simple as taking an aluminum piston and replacing it with a steel piston, because it has a big impact, particularly in heat transfer of the entire system. And it almost requires a complete redesign of the engine from all aspects to make those combinations work. It does work. It's a very effective material for a piston, but it takes a lot of development to get there. So I think it's coming, but just not quite there yet.
Well, we've got pretty much a specific question from Ron, and he wanted to know about your diesel pistons that's already out there and your coating on those, and why are they coated?
Yeah, well, ironically, and thank you, Ron, our diesel pistons, we coat the same way we do almost all of our gas pistons. We have what we call graphol that we put on the skirts, and it's a process we do in-house. It's graphite impregnated. It's there for friction reduction, a little bit of scuff resistance.
Right.
But because we can do it in-house efficiently, quick, very inexpensively, unless there's a piston that absolutely, or a customer that absolutely does not want it, or a class where the rules won't allow it, we coat everything we put out the door with that skirt coating. And it's the exact same coating on gasoline versus diesel, motorsports versus what goes into some of the OEM production that we do, that, where it's expected to last 100, 200,000 miles, the life of that vehicle. In addition to those, there's some specialized coatings that we do in terms of anodizing ring grooves. We'll do some thermal coating on the crown for customers that want that. So there's options out there. Our gasoline pistons also have an additional dry lubricant that's a phosphate coating that covers the entire piston. That's what makes our piston kind of the unique blackish dark gray color that it is. So yeah, we're a very firm, big believer in coatings. But again, they're all available, but it's fine tuning that coating to the application and what you're trying to run with it and what you want to run.
Well, and when you say what you want to run, we've talked diesel, we've talked V8s. I know you guys make pistons for everything. So Dwayne Wagner wants to know what's, unique characteristics of a two-stroke piston that maybe is that's different than just what we're kind of growing up thinking, well, this is the way a piston needs to be designed here versus there.
Yeah, unique in terms of the thermal properties of it, trying to maintain expansion and growth, particularly because a lot of them tend to be running, air cooled in the past, and whether it's air cooled or water cooled is going to dictate it, whether it's two stroke or not. And also you have some unique lubrication issues just because of the way that those engines are run, and that's in effect a good segue from the quotings in terms of being able to take a marginal situation and provide you some added insurance when lubrication can become compromised or by design has a mix of what's there. So there's geometry issues with them, and you have to take into consideration how the rings are going to be arranged and ports and things like that. And there are unique challenges for them, but I guess I don't want to downplay it, but it's kind of similar to what you would see in most other applications where, again, you start stacking up the variables and put all that together into a final design.
With all this we kind of brought out, is there anything in your schematic that you had as far as where you can show us where some of these developments that y'all are making or some of the challenges that you've run into where you can address that, as far as the skirt height and things like that? Because again, you just showed us a diesel piston and it's got long skirts on it, let's face it. And then you got other ones I'm thinking more about like a two-stroke piston, very, very probably real short. Again, don't have the room in there to do a lot of stuff. And how you kind of like deal with that? Can you explain, like say all the challenges, man, like say you have got, the ultimate, anything that runs, those challenges that you just like have brought out in this, like, wrist pin, stroke, just whatever you can allude to that help us better understand.
Sorry, Jeff.
Yeah.
See, I'm going to jump ahead here as we're doing, and you talked about trying to develop profiles. And this is an example of a part that, sometimes guys will take parts off the shelf and kind of mix and match rod or stroke combinations to build something new, or as new combinations are put together. This was one that was put into a very long stroke motor that pulled out of the bottom of the cylinder, and we just weren't aware that was a combination that existed, or that's how it was intended to be used. And so then when they kind of send it back for analysis or shoot us some pictures over, we're able to look at that, collect, the information that we need. And this is just an exaggerated view of what we're talking about, calculate where on the piston on that skirt are we pulling out of the cylinder. And so we'll use that. Let me find my, right above it. To dictate how we shape what I'm going to call the profile of the piston. Now, this is quite simply just a 2D representation of that shape. We use it to visualize it, and it's scaled for visualization. A representation of the skirt axis of the piston, and then inside is the pin axis 90 degrees to it. So the offset indicates that there's some ovality to those lands, and ovality to the skirt, which I think is common. Most everyone is familiar that there's not, pistons aren't round to the eye, yes, but there's shape almost everywhere to them that you look, and there's a lot of different nomenclature that can be used for that, whether it's cam, the barrel, drop, taper, whether they're cylindrical parts, oval parts, etc. We wrap all that together in one nice internal terminology and call it the piston profile. And that kind of encompasses a little bit of everything that we're talking about, and just is a quick and easy way. So as you hear me say profile, I'm talking about essentially the shape of the piston, how it's turned in the final machining. So, sort of the nice visual over here, we took a piston after it had been machined once and then came back, reprogrammed it, and through the turning operation, the same finish turn operation that normally cuts the skirt, we're able to write our name in that piston as it's turning. So that's the level of detail and essentially infinite parameters that you have available in terms of determining that shape. There is no one correct shape, no right or wrong profile for any piston, and there is no one shape that works for every piston. This is something that we try to develop, again, being very application specific. Mm-hmm. And so with those variables, determining, depending on whether it's heated or it's, if you're trying to manage heat, or you're trying to, which is controlling the expansion or growth of the piston, or if you're trying to use skirt shape and profile for friction reduction, or you want to, you can actually use the skirt to control how the part is lubricated. All those variables can come into how the ultimate shape is defined. And with the ability to fine tune that, part by part, and to particular engine families, and different, a circle track profile might be different than a drag race profile. Again, because those engines are going to be used differently, we have that ability to fine tune it and build it into what the final part would look like. I did see a comment, and while we're talking about profiles, about the asymmetric barrels and different thrust to non-thrust application. And it's interesting because, yes, absolutely, but it also takes a lot of development and testing to make sure that what you're doing is working. There are applications where, if you look at asymmetric, let's just say, simplify it to asymmetric skirt shapes. We've seen big skirts on one side, little on the other, and you'll see that where the big skirt is on the thrust side, and the little skirt anti-thrust where the loads aren't as high. But there are applications, and we make applications in production engines where it's 100% reversed, because the way that you shape not just the skirt, but the structure behind it and how that profile is shaped, there's advantages to running the little skirt on the thrust side, the heavily loaded side, and running a bigger skirt on the anti-thrust side. So application. But yes, there are instances where that can and will make a difference.
With all that being said, and in the very beginning, we talked about the application and the communication to make sure you get the right information. You showed us the one that you could clearly see the bottom of the skirt had been coming out of the cylinder.
Yep.
And again, this is my being novice. Where was the miscommunication, and what did the engine builder not share with you guys? Where did they make that misstep at? What part did he not give your company to keep from doing that?
Well, that particular one came in after the fact. It was someone who had bought an off-the-shelf part, and compression height, pin size, everything lined up to physically fit the application that he needed with the stroke and rod that he was using, and it fit his head, and everything there was right. But because it was I believe it was a longer stroke than what we had intended that part, somebody came out with a shorter rod version of that. So it was pulling the piston out further than we'd ever thought it would on a particular block. The other part is, the proliferation of parts that are out there continues to grow daily. So new blocks come out, they don't all have the same cylinder lengths. Cranks come out, they don't all have the same counterweight clearances on them or same size of counterweights on them. And we can't fault anyone for doing that. Everyone's going to evolve and improve their products, but all of those variables have to work together. And so this was a case of where they had came up with a new bigger cubic inch stroke combination, and here was a part that fit it, but overlooked that one variable of, okay, now it's, half the piston is out the bottom of the cylinder. And knowing that existed, we were able to go in, make a profile adjustment to the parts, and then, and actually started cataloging it for that new combination that was out
there. Okay. Well, like I say, that everything that you're explaining, and the way it comes out, it's that again. I was just trying to understand. I think I do now that, as much information as you give, one misstep as far as one part of that explanation, if it's missent or misinterpreted, that's how you run into a situation like that. It looks to me like, the engine didn't fail, but it didn't perform properly. I mean, right. So what's the telltale sign when you're having something like that going on? Just a loss of horsepower?
I don't recall, but noise could be an issue.
Okay. A little rattle in the engine itself.
If it starts rattling a little bit, and particularly as you start to run a little bit of a groove, or you saw it had taken the coating off, and so the clearance there is going to be changed. So you might get into some rattle whenever the piston changes direction, or it may have been a problem when it was cold. But typically something like that, noise and starting to this one probably wasn't blow by, but I would think noise and blow by are probably two of the biggest issues where guys start to question what's going on and what's happening.
We again, reading a lot of the questions right now that they're leading us off into almost how much testing do y'all do in-house on your products as you're developing them, and not just maybe computer generated. How often y'all do actually, your own engine dyno testing?
Yeah, and to touch on that, I think it also touches on the previous question about simulation. How good is it? It's
exactly
excellent. But really good simulation is very expensive and very time consuming. Mm-hmm. And coming back to the whole concept of data and variables, if you don't have very specific inputs to feed into the analysis, you're not going to get the results out. You can get estimates, you can get A to beta comparisons, but the better data that you put in terms of temperature estimates for pistons, cylinder distortions, all that feeds into having an accurate model. And when that's available, it's excellent. Very infrequently is that level of information outside the OEs available, particularly to the average, even the professional engine builder. It's not as often as we'd like it to be, but we're still able to work around and find good information that we can glean from it. Testing is very difficult because it comes back to the proliferation of applications. And the reality is our customers are better engine builders than we are. So even if we could have a dozen engines here in-house and build them and test them, but there's 6 dozen engines that we don't have. So the truth of the matter is, no matter what we do in-house, we still see better feedback from customers, people that are building the engines, that are pushing them, and pushing them in ways that we're not imagining. That's where the good feedback comes from. And, that sounds like we're passing it off a little bit, but unfortunately, the industry actually fortunately for the industry, the builders and guys that are out there racing are pushing parts and pieces, to levels that it's almost impossible to do in-house and not, the customers are very good at giving you good, quick feedback in terms of what works and what doesn't.
A question here, because again, working in the business like I have been in for so long, is proprietary information. You're going to have, people like Elmore, Hendrick, Roush Yates. I mean, they're going to come to you every now and then. They're going to say, okay, we're doing this. When they're working with you, and yet when you maybe they bring you something and all of a sudden, this does work, and yes, this will work a lot of different applications. How do you control what is, theirs and what, you would like to build, like, you utilize in your own, and other engine sources, you know what I'm saying? Do you run into the problem of when they bring you something, they don't want TRD or, Chevrolet to get hold of it for the Roush Yates deal? How hard is that?
Is this a setup?
No, it's not a setup. It's just I know how edgy sometimes that can be, especially in a company in your spot, is that so much and you do so much, and like you say, every now and then you're going to run into a situation where it goes, And again, I'm just running to it. Johnson, whoever.
It's very interesting because it is something.
This is ours.
It's something that we do deal with quite frequently with them.
Yeah.
It's interesting that we see more secret information from teams come from other teams than stuff that we leak out. Other teams asking us about, hey, we saw this, can we do this?
Yeah.
But that's out of our control. But a lot of it is, even though some of the problems are similar, the approaches to solve them still end up being unique. And it's amazing that there is still that much disparity between it, because I could lay out a current, FR9, the R07 and Toyota's piston on the table in front of you, and to the untrained eye, very, very small group, you wouldn't be able to pick out which is which. But yet they're all unique. And there's things that, even though they look similar, that doesn't work for this engine that works for the other. So we can apply some general knowledge, and that's the advantage of working with a manufacturer that gets to see a broad variety of things. You're drawing on their information, their background, without having to cross over into confidentiality and specific things that we just can't share and don't discuss. And particularly, the bottom line is you just don't do it. That's how you maintain those customers and their level of trust. I'll share one more last quick thing with you, just because we're talking about that subject. So I had brought up a picture of, let me see, find it real quick. Skirts. Talking about what a good skirt wear and everything looks like. So the picture on the left, those are NASCAR pistons, but they're old enough that they weren't going to get me in trouble that I could show them.
Right.
But you also can't see much of what's going on there, and that's a full. I think that was still back single race season. And so I had to cut and crop what's going on here on the right for a current part that shows. I don't know if it shows really in the video, but there's a kind of a shadow that you can see, and
yeah, you can see it
where there's wear. Yep, and that's a full 1,000 miles. That's in the life, but still looks very good, etc. But and I bring that up just because there's always questions about, should the coating last? Is it a break-in coating, etc. And no, when things are right, it'll look brand new when it comes out. But the other part is, and I'll caveat that by saying, nobody learned anything there secret, because that profile through a lot of iterations was developed for that engine, for the clearance that they run, for their cylinder wall finish in terms of how it maintains lubrication, and the temperatures that they run their engines. You could take that same profile, put it on somebody else's piston, and it's not going to look like that.
Mm-hmm.
So it's there in those types of engines, we have the luxury of doing a lot of development work, a lot of A to B testing, where we can iterate in very small, fine increments and refine those to get to that level of running wear and the performance that we want. But it's not universal, because it's dependent on the application.
Right. Well, real quick, we got several questions I want to try to get to real quick. Delmo Martin, he runs a machine shop, and he requests a lot of his customers wanting him to sell MAHLE parts. Is there a way they can go to that, go to your website or through EPARTRADE to be able to become a dealer for that real quick? And John Zamansky also wants to know, does Lee Morris still work at MAHLE?
Lee Morris has retired. I don't know that it off the top of my head. It's been a number of years.
Yeah.
But yep, Lee was here for a long time, and Lee was here when we got started.
Right.
But certainly on the website, MAHLE Motorsports, NA for North America, or our toll-free number, 888-255-1942. Again, MAHLE being a large corporation, that's not a number that's going to get you into a switchboard where you have to go through 16 people to find somebody that knows what you're talking about. That's directly into our sales and engineering office, which is just a handful of guys here that I can probably hear down the hallway, half of them at any one time. So that gets in a same number for tech, for sales, for stock checks, any inquiries that we have. Happy to talk to anybody about that at any time.
Yeah, well, I tell you what, man, you've helped educate, I think, a lot of folks out there today. A lot of people, like I say, asking a lot of questions there, and you were very generous of showing, hey, we're not indestructible. You want to share that with us? and explain the reasons why. I mean, again, cause and effect has always been the biggest problem with any kind of racing or any kind of product. You got to kind of throw it to the wolves every now and then, and you got to learn from your mistakes, and you got to develop a way to get better at what you're doing. It sounds like Molly's doing a great job. And like I say, 18 years worth of effort on your part. I can really still see the passion right now when you're trying to describe what you enjoy doing, and that's taking on all the challenges, no matter what it is.
Well, we appreciate you having us, and frankly, it's outside of the shows and things like PRI, we don't get the opportunity to do that. And even at the show, you're standing talking to a guy, wishing I had some data in front of me that I could show you, because I could say things all day, but if I can put some numbers in front of you and explain what's happening, it would. I think it goes a long way. I see someone's asking that number again, 888.
Yep.
255-1942.
Yeah, thank you for that. Yeah, we had a couple people wanting to do that, and I'm thinking right now we're going to be joined by Francisque. And Francisque, you can help people. Some people asking about the presentation. Can they get a copy of it or watch it again?
Yes. Eric, brilliant work. Doing it by yourself for a full hour. You made things so simple. We had two other engineers earlier this week who dynamics chassis simulation in just a brilliant way, just like you did, to make it understandable for all of us. So thank you very much. Please send over the presentation. We'll upload it on EPARTRADE on the MAHLE's account if you want. I mean, it's up to you.
Registering on EPARTRADE is easy. Fill out your name, email, phone number, and create a secure password. Next, select your business type. Choose supplier if you're looking to display products or services and connect with buyers. Choose racing business if you're looking to find new parts and connect with suppliers. Choose race team if you own or are a member of a professional racing team. Begin typing your company name. We most likely already have your company in our database, which you can select from the drop-down. Then, enter your job title. Choose Claim Company if you'll be editing your company profile. Other members of your company can choose Join Company if they'd like to use EPARTRADE as well. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Click Register Now, and your registration will be submitted for approval. You'll need to confirm your email once it goes through. To keep our platform industry only, you'll be approved shortly after. If we require additional proof of business, we'll reach out. Welcome to EPARTRADE.